Hi everyone again. Okay, this is part 2 of 11.1 on sequences, our intro to chapter 11. I noticed a couple things. The clarity of what I've written here on this page didn't come through in the last video as well as I was hoping. So I can even see now some of it's a bit blurry. I'm going to try and do better with that. Hopefully I'll get better at filming these as we go. Also, I don't know why, but I was not able to use YouTube's automatic closed captioning in that first video. Maybe I need to speak a bit clearer. I'm not sure why it wouldn't allow that, but we'll see what happens from here out. Okay, and I think generally, hopefully, these will get better the more of them I do. Anyway, we have looked at lots of examples. We're just defining what a sequence is, kind of getting used to the whole idea. Now we're going to get into some calculus, taking the limit of a sequence. This is what we need to move forward when we talk about series in the next section. Okay, so the limit of a sequence, as you can see there, we take the limit of the nth term as n goes to infinity. What's happening as these terms go off, as n gets larger and larger, right? So there's two possibilities. Perhaps the answer to that limit is a finite number. Then we'll say that the sequence converges to L. Or maybe L is infinity or negative infinity or simply does not exist. In that case, we'll say the sequence diverges. And you notice the same language that we used with improper integrals. And it's the same concept, right? Does it converge or diverge? Okay, so that's the nature of our first example. Find the limit or show that it diverges. We're just going to look at a whole bunch of examples, starting with this one. Okay, again, that's a little bit blurry. I don't know why. Maybe if I push it this way a little bit, I'm not sure. Okay, anyway, an 4 minus 3 over n. Okay, so we're just going to say, all right, what's happening to the sequence? We take the limit. Looks like I kind of gave it away already. So we take the limit as n goes to infinity. We notice, oh, this one is just 4 minus 0. So the answer is 4. And what do you know? It converges. And to be proper, I guess, we would say that it converges to 4. The larger the value of n, the closer the term value is to 4. Okay, that's kind of a nice one just to get used to the idea. Let's get it into things that are a little bit harder. How about this one? A sub n equals 1 plus negative 1 raised to the n, like so. Pull that to the top here. Okay. So if we think about the limit, apply a limit to it, and say, well, as n gets bigger and bigger, is the whole thing going somewhere? Is it going to one place? And, well, no, it's not. And it's maybe kind of difficult to describe that exactly. You think, okay, as n goes to infinity, the value of our sequence alternates between 0 and 2. Right? So if n is odd, then it'll be 1 minus 1. If n is even, it'll be 1 plus 1. And so it's just going to jump back and forth, 0, 2, 0, 2. There's no limit value, and I kind of like really gave some details there. Well, here's the answer to the whole thing. I might as well just reveal it at this point. A1, plug that in. It's going to be 0. A2, it's going to give you 2. A3, back to an odd number, it's going to give you 0, and we could keep going. And then I drew it out. This is helpful also just to help wrap your head around a sequence or a series. You can see, oh, okay, for n equals 1, and for sequences, we always start at 1. It's 0, and it jumps back and forth, 0, 2, 0, 2. So there's no converging value that it's honing in on. And it's not that it equals infinity, of course, it just, the limit does not exist. So we say it diverges. Okay, okay. Hey, let me encourage you, pause if you need to at any time. I really apologize if I'm going too fast. Oh, I gave that one away. My mistake. Okay, let's change it up a little bit. Just pretend you didn't see that. Let's change it up and say, hey, let's make a sub n 1 plus negative 1 to the n divided by n. What might that do? Oh, okay. So again, we'll think of the limit, right? And okay, well, I gave it away. So the numerator does not exist on its own, but if we divide by n, all of a sudden we have an answer. As n gets bigger, this is going to go to 0. You think, well, what's up with that? Because it did not exist for the numerator. How can it exist if we divide? Well, I think the drawing is really helpful. You think, all right, if n equals 1, okay, it's still equal to 0. But now if n equals 2, it's 2 divided by 2, and we get 1. For the third term, n equals 3, well, it's back down to 0 because our numerator is 0. But at n equals 4, now we've got 2 divided by 4, it's 1/2. At n equals 5, back to 0. But n equals 6, now it's 2 divided by 6, and it's at 1/3. And you can say, okay, the odd values of n are still going to be 0, but now the even values of n are converging to 0 as well. Everything's headed towards 0, even though there's this jumping thing going on. That limit value is approaching 0. Again, the drawings, I think, really helpful. If you're not sure how to get started, making these drawings is a good place to begin. So it turns out D is going to be a little bit different. Different approach to this one. A sub n equals the natural log of the square root of n, all divided by n. Okay. What's happening to that as n gets bigger and bigger? And okay, well, I'm sort of giving it away by showing you all this. Well, you think, all right, so yeah, n goes to infinity. Well, then the numerator would be headed to infinity. The denominator would also be headed to infinity. We've got infinity over infinity. And maybe you recall from Calc 1, if you took that here at this campus with the book that we use, L'Hopital's rule. It's infinity over infinity is one of the indeterminate forms. We don't have an answer yet. We need L'Hopital's rule. Maybe the answer is infinity. Maybe the answer is 0. It could be that the answer to this limit is somewhere between 0 and infinity. We don't know until we apply L'Hopital's rule. So if L'Hopital's rule is not familiar, I'm not going to spend much time on it here. I'm going to expect everybody knows how to do that. Go back, maybe a quick Google search, jog your memory. Or if you want to continue on, the idea is that we take derivatives of the numerator and denominator separately. So we think, okay, I don't know the answer to this limit, so the derivative for natural log n to the 1/2 will be my new numerator, and there you see it. And the derivative for n, and there you see that. Like, okay, so I can think of it this way. Maybe I can clean it up a little bit, a little simplifying. Again, hopefully I'm not moving too quickly. All that would clean up pretty nicely as 1 over 2n. So, okay, so I've applied L'Hopital's rule, then I've simplified. Can I take the limit now? And yep, I can say the denominator is going to infinity. If the denominator is going to infinity, then the whole thing headed towards 0. And the answer to this one, that sequence converges to 0. So I've got one more example. Quite a few. I'll try not to give this one away. This one, hey, finally we get something that involves a factorial. Probably wise to chat about one of these at this point. Yeah, trying to not have it be so blurry, but okay. A sub n equals n factorial divided by n minus 2 factorial. You would not want to think about the limit of this one as it is. If you did take the limit as it is, well, what would happen? Infinity over infinity, right? You might think, oh, well, no big deal. I'll use L'Hopital's rule. You do not want to apply L'Hopital's rule to a factorial. You don't want to take derivatives of something like n factorial. There's another way. It turns out we should break these factorials down a little bit. Let's think, I'll just show you the whole thing. Let's think of n factorial on the top. As what it is, right? N times n minus 1 times n minus 2, etc. And in the denominator, n minus 2 factorial, well, n minus 2 times n minus 3 all the way down to 1. And we notice this really nice cancellation. The only thing that comes out of this is n times n minus 1. So really, this sequence can be reduced nicely to n times n minus 1. And if we think of the limit, well, the answer comes out immediately. As n goes to infinity, you've got infinity times infinity, which is infinity. This one diverges. Okay, that's the end of this video. We've got one more part to 11.1. I'll see you guys in the next one.